Hi guys, this is Mr. Adams from Midwood High School, and this video is working two problems from the most recent homework in relation to half reactions. All right. Now I chose these two problems because they look kind of intimidating, but they're really not that bad, folks. Okay. Now remember, we have to be able to assign oxidation numbers, and we also have to be able to figure out what substance got oxidized and what substance got reduced. Okay, so let's assign the oxidation numbers first. Now, we know from experience, right? Sodium, Na, is in group 1, so it's always going to be what? It's always going to be +1, right? We know O is -2 most of the time, and H is going to be +1, okay? So that's sodium hydroxide. Now, this guy right here, calcium hydroxide, okay, Ca, calcium, is in group 2 and is always going to be +2, right? O is going to be -2 and H is going to be +1. So that's calcium hydroxide. Now, this is carbon by itself, and that should be easy. If the element is uncombined by itself, neutral, what's its oxidation state going to be? Yes, it's going to be 0. Okay? Alrighty, moving on. We have ClO2 right here, chlorine dioxide. All right, so we know most of the time oxygen is -2, oxidation state. Now, if we have two oxygens, right? Two oxygens would add up to -4. So the question is, what plus -4 gives you 0, right? And that is +4. So that chlorine right there is +4. Okay, moving on. Sodium, group 1 metal, is always going to be +1. Oxygen, most of the time, is going to be what? Is going to be -2, right? So let's do some more calculations. We have two oxygens here. That's going to give us what? That's going to give us -4, right? Okay. We have one sodium there. So that's going to give us +1. So the question is, what do I put in our box right there to make everything 0? We have +1 here. We have -4 there. So we're thinking that we need to put +3 in the box. So +3, okay, is the oxidation state of that chlorine there. Okay? Alrighty. So let's move on. Calcium, group 2 metal, always 100% of the time will be what? Will be +2. Okay, oxygen over here is going to be -2. Now let me use a different color. Now the question is, okay, what is the carbon? That carbon right there, what's that carbon going to be? So I'll do it under here. All right, so we have three oxygens, and each of them, it's -2, right? So those three oxygens are what? Those three oxygens have a total charge of -6, but we put -2 for the oxidation state. Don't put -6 above. That's a big no-no. Okay, we don't know what that carbon is, right? Okay, we don't know what that carbon is. Okay, but we do know what the calcium is. So calcium is +2. Plus carbon, which we don't know, and the three oxygens give us -6. So what do we put in this box, folks? Okay, to make everything 0. Okay, if you have +2 there, you have -6 there, you're thinking that you got to put +4 here, right? Okay, 2 plus +2 and +4 give you +6. You add -6, you get 0. So +4 is the oxidation state of that carbon right there. H, okay, most of the time is +1, and O most of the time is -2. All right, so let me create some space here, get rid of these calculations. Now, what is our next step? We have to recognize, right, what substance got oxidized, what substance got reduced before we can even start doing the half reactions, okay? So here's the deal. We're going to look at the reaction, okay, with all our oxidation numbers, and we're going to look to see what's changing oxidation number from the reactant side, which is this side of the arrow, okay, over to the product side, which is this side of the arrow. The arrow's right here, right? Okay, so we notice Na did not change from left to right, from the left side, from reactant side to the product side. We know O didn't change, okay? They're all -2s for the O's, they're all +1 for the NAs. We notice H did not change, right? H is always +1 everywhere you look, right? Okay, we notice CA from left to right, CA did not change. CA is +2 on both sides. But the thing is now, when we look at carbon, right, C, carbon, we notice that carbon goes from what? It goes from 0, oxidation state, okay, and it changes to, over here, +4, right? So you write that down. If your oxidation number, right, if your oxidation number increases, you're the guy that got what? You're the guy that got oxidized. So this guy CO got oxidized. So in terms of your oxidation half reaction, right? You write this. You write CO down, all right? You write your arrow, okay? And you put C +4. The oxidation state on the product side. Notice I don't have any other elements, people, because all the other guys that we talked about, the Na, the O's, all those guys, they're spectator ions in this case. Okay, their oxidation number didn't change. They didn't undergo redox. We're interested in this carbon right here and this carbon right here because that shows the increase in oxidation number. And since we're undergoing oxidation, right, we know we're doing LEO, okay, loss of electrons, oxidation. And in the previous videos, people, where do you show the electrons if you're undergoing LEO? Okay, we put electrons where? We put them on the product side. And the question is now, how many electrons do I put on the product side? Do I put a random number, or what am I doing? We want both sides of this equation, right? All right, we want both sides of this equation to be equal in charge, okay? So here's the deal. If we have zero on total charge on this side, okay, this total charge is 0, what do I need to make this side 0? Okay, question mark. This is 4 plus right here. So 4 plus and 4 negatives gives me 0. So this right here, C0, arrow, C +4 electrons, that's going to be your oxidation half reaction. Okay, so that's the first guy right there. Let me get rid of some of this right here so I can do some work. Okay, alrighty. So get rid of that. Now we want to do what? We want to do our reduction half reaction now. Okay, so let's do a different color. RED, right, for short, reduction HR. Okay, now you look at the equation and tell me what substance from left to right went down in oxidation number. We notice, right, that Cl, okay, goes from what? Goes from +4 to what? To over here, +3, right? Cl +3, okay. Now its number is going down from 4 to 3. Now for reduction, right? For GER, where do you put the electrons in the half reaction? You gotta put them on the reactant side. So how many electrons you think we're gonna put if you're going from 4 plus here and 3 plus there? We only need to put 1 electron and you're done. Notice another thing, folks. This is a big one to show you right here. You see this 4 in front of here? I ignored it, right? I didn't bother putting it anywhere. It's totally legit for you to pull that and ignore the coefficient, all right? So these two guys right here are your answers, and you're done. All right, so let's do another one. We have Cu right here by itself. So the oxidation state is going to be what? It's going to be 0. H is going to be +1. O most of the time is -2. Now nitrates we've done a number of times, right? Now there's a number of ways to do this. Now we know we got 3 oxygens, and each of them 3 oxygens, and each of them is -2. So what's 3 times -2? -6, right? We don't know nitrogen just yet. That's our question mark. Okay, and we have 1 hydrogen there, so that's +1. Okay, So what do you think is going to go in this box right here, folks? Okay, it should be +5, right? So +5 is the oxidation state of that nitrogen right there. Okay, we're moving on. Arrow. NO, nitrogen monoxide. We're going to put a little -2 there because that we know that's the majority of the time that's what oxygen is. And what makes -2 0? You add +2 to it. So that +2 is for that nitrogen right there, right? Okay. Copper here, though, is not going to be 0. It's in a compound, right? So it's not going to be 0. We're not going to panic. Let's do what we know, okay? We know for a fact, right? There's a shorthand we can take. We know that NO3 is a polyatomic ion with a -1 charge. Let me ask you a tough question. What's 2 times -1? 2 times -1 is -2, right? Good. So that's your total negative charge. So what plus -2 gives you 0? +2. So +2 is for that copper. The nitrogen is going to be +5. We calculated it before. And O is -2. Okay? And let me make some space right here. Let me get rid of that. Okay, so what's H going to be? H is +1. O is -2. Make some more space. Get rid of this. We're almost there. Okay, so while I'm erasing stuff, I want you guys to tell me what got oxidized. Let's look at it carefully. Okay, for my oxidation half reaction, what am I going to do? Okay, we're going to look for something whose number went up. Now, there's 2 ways to do this, guys. If you look at this guy right here, this copper, he's going from what? He's going from 0 to +2 right there. Now, you can use 3Cu0 arrow 3Cu +2, right? Now, you got to put some amount of electrons on the product side. How do I know? Because it's undergoing Leo, and for Leo, we always put electrons on the product side, right? So this is 3 times 0, so that's 0 right there, okay? Now, what's 3 times +2? 3 times +2 is +6, right? So what plus +6 is going to give me 0? I need 6 negatives. So I'm going to put 6 electrons right there. Now, the question is going to come, can I reduce these guys right there? Absolutely. So you can write Cu0, because everything is, all the 3's go into each other. 3 into 3, that's 1, and 2 goes there, right? So you can have your final answer as Cu0, arrow, Cu +2, okay, plus 2 electrons, okay? So either or of these answers are absolutely fine. Alrighty, let's do a different color. I'll do green. All right, let's wrap this up. We have nitrogen right here, right? And he's what? He's in a +5 oxidation state, right? And what is he changing into? He's changing into this. Wait, it's good. Yeah, he's +5 oxidation state, right? And he's changing into this guy right here, and +2. I got almost confused because I was looking at this nitrogen over here. It didn't change. Okay, no problem. So we're going to write down for our reduction half reaction, we are going to show GER. How do you show GER? You need electrons on the what side? On the product side, right? You're making notes of this. All right, so you're going to write this down. N, right? +5. Okay? Arrow. N, okay? +2. The oxidation number went from what? From 5 to 2. 5 to 2. The oxidation number is going down, so you know it got reduced. What do I do, people? I have to put electrons on the reactant side. How many electrons do I need? I'm going to need 3 electrons, right? Because 3 negatives plus 5 positives gives me +2. And this right here, folks, is my reduction half reaction. And I can use this, okay, or this as my oxidation half reactions. As always, guys, hard work plus sacrifice equals success. Okay, I hope you guys get a bit of better understanding of how to do these half reactions. You're using the skills you did before, folks, in terms of assigning oxidation numbers, recognizing who got oxidized and reduced, and you're only isolating the elements that got oxidized or reduced, nothing else, not the spectator ions. And hope everyone's, please be safe. Okay, follow precautions, and we'll get through this. Take care.